My name is Luna. I heard you want to learn about astronomy and astrophysics, so let's get started. Astronomy is a natural science that studies celestial objects and phenomena. It applies a wide range of subjects, such as physics, chemistry, mathematics, biology, and geology, in an effort to explain the origin of objects like stars, moons, comets, planets, galaxies, interstellar medium, phenomena like supernova explosion, gamma ray bursts, and their evolution. It is arguably the most ancient natural history in human history. Babylonians, Greeks, Indians, Egyptians, Iranians, Chinese, Maya, and many indigenous people of the America performed methodical observations of the night sky. Thousands of years ago, our ancient ancestors have already looked up to the night sky for patterns, navigation, the creation of calendars, or simply out of the curiosity of the universe we live in. Astrophysics is a branch of astronomy that particularly interested in the nature and principles of celestial bodies more than their positions in space. The study involves many disciplines of physics, including mechanics, electromagnetism, thermodynamics, quantum mechanics, relativity, nuclear and particle physics. Some topics explored by astrophysicists are the formation of solar system, stellar dynamics and evolution, large-scale structure of matter in the universe, origin of cosmic rays, as well as general relativity and physical cosmology. They also attempt to understand the concepts and properties of abstract objects and unsolved mysteries, like dark matter, dark energies, and black holes, whether or not time travel is possible, wormholes can form, or the multiverse exists, and eventually the origin and ultimate fate of the universe. Right now, let's start off with the history of astronomy. The development of astronomy is certainly a team effort, with the devotion of astronomers around the world from thousands of years ago to the present day. The knowledge we have and the progress modern astrophysicists are making today are only made possible by our ancestors' collective efforts. Some of the following have been key contributions to the process. It started 5,000 years ago with the ancient astronomers from Egypt, Maya, China, Babylonia, and later Greek. The Babylonian astronomers recorded celestial objects on Sumerian clay tablets, inscribed in cuneiform. Along with other cultures, they developed a system of calendar, using the lunar cycle, the phase changes of the moon. They had also developed arithmetical techniques for astronomical phenomena. One example would be to compute the distance that Jupiter traveled by measuring its average velocity over days and calculating the area under the curve. Influenced by Babylonian astronomy, Greek astronomy is characterized by seeking a rational, physical explanation for celestial phenomena. Most of the constellations of the Northern Hemisphere derive from Greek astronomy, as are the names of many stars, asteroids, and planets. Eratosthenes is a Greek astronomer who also had contributions in math, history, geography, and music. But what he is best known for is the first person to measure the circumference of the Earth with relative precision. All he used were a stick, some traveling, and an ingenious mind. It was in the year 276 CE, Alexandria City, modern-day Libya. One day, reading in a library, Eratosthenes learned of a well with remarkable properties situated near the town of Syene in southern Egypt. Each year, on the 21st of June, the day of the summer solstice, the sun shone directly into the well at midday and illuminated it all the way to the bottom. That means that at that particular moment, the sun is directly above Syene. He wondered if he could exploit this property to calculate the circumference of the Earth. On the day of summer solstice, he put a stick on the ground and measured the angle between the stick and its shadow at 7.2 degrees. Then a person he hired walked from the city of Alexandria to Syene and recorded the distance as 5,000 states, which means the distance of a step. We know a full circle is 360 degrees. So let's divide 7.2 degrees by 360 degrees, which can be simplified to 1/50. This angle ratio is the same as the ratio of the distance the man walked over the Earth's circumference. Thus, the circumference of the Earth will be 5,000 times 50, which is 250,000 states, around 39,250 kilometers, only 2% bigger than the actual circumference. From this example, we can see how our ancestors gained an understanding of the universe without the existence of sophisticated tools. Now, let's go back to the big history line. Although Greek astronomers like Eratosthenes and Hipparchus were able to measure the circumference of planet Earth and to create a star catalog, their belief in the geocentric model prevented them from understanding the true structure of our solar system. As early as 4th century BCE, the Greek philosopher Plato raised the geocentric model, who believed that the Earth is the center of the universe, and all celestial objects and orbits are circular and regular. This Platonic model was widely worshipped by Greek scientists. 600 years later, in the 2nd century, Ptolemy published the Almagest, which included a star catalog and a list of 48 constellations. It remains as one of the most influential scientific texts all the time, although it still had a static view of the universe, where the Earth is the absolute center. In fact, it was not until 1,200 years later that Copernicus challenged the geocentric model in early Renaissance. The publication of Copernicus' heliocentric model, which means sun is the center of the system, in his book on the revolutions of the celestial spheres in 1543, was a major event in the history of science. The revolutionary model triggered the scientific revolution, which made a huge impact on Galileo 30 years later. The father of scientific method, Galileo, used a telescope for methodical observations of celestial objects. He published Starry Messenger, describing the findings with the telescope he built. These include dark spots on the sun, craters on the moon, and 4 satellites of Jupiter. Galileo proved the heliocentric model with his observation of phases of Venus. 75 years later, in 1609, Johannes Kepler announced his 3 laws of planetary motion in his work The New Astronomy, replacing the circular orbits of Plato with elliptical ones. In 1697, Newton came into play with his 3 laws of motion and the theory of gravitation. Astronomers, for the first time, were able to systematically understand the gravitational forces acting between the sun, the planets, and their moons. Newton's classical mechanics was widely accepted for 200 years, until Albert Einstein, along with Albert Michelson, Hendrik Lorentz, and others, developed the theory of relativity in the early 20th century. The theory transformed the world of astronomy. It introduced concepts like space-time that combines space and time as one unified entity. Relativity explains the super high-speed, gigantic-scale celestial phenomena that Newton's physics failed to explain. It also predicts the existence of black hole, gravitational wave, and constantly influencing scientific discoveries today. While relativity explains massive phenomena, scientists including Richard Feynman and Julian Schwinger developed the model of quantum mechanics to illustrate the objects and interactions in a microscopic scale. Classical physics do not apply for the movements of atoms, electrons, or photons. Although general relativity and quantum theory are well supported by rigorous and repeated evidence, there are still, nevertheless, discrepancies between them, and they have yet been incorporated into one unified, cohesive model. In fact, searching one elegant mechanics of the universe is one of the ongoing missions of modern astrophysicists. Stephen Hawking, one of the most well-known scientists of our time, was among the first to set out a theory of cosmology explained by a union of relativity and quantum mechanics. Also, his contribution in the property of black hole has laid the groundwork for future discoveries. Although we have come a long way from 3000 BC to 2019, from geocentric to heliocentric, from naked eyes to Hubble telescope, there is still much, much more than we don't know than we do. What came before Big Bang? Who set the clock of universe? What are dark matter, dark energy? Are we alone? Are there other intellectual lives out there? The searches for aliens, exoplanets, and a more unified model of the universe are still young in their progress. The development of our studies in astronomy is only made possible by the incessant effort and the lasting spirit of exploration by centuries of scientists. The desire of knowledge, the curiosity of the system we live in, the quest of a fundamental truth to be part of a human tradition, all of this and more are reasons that why we should learn astronomy. Standing on the giant's shoulders, our generation continues looking up to the stars. Thank you for watching the first episode of my series Astrophysics, The Journey of Stars. This video is written and produced by me along with my project instructor, Mr. Decorado. If you want to learn more about the interesting topics that we briefly talk about today, please stay tuned for the coming episodes on stellar formation and stellar evolution. Enjoy your day and don't forget to keep looking out to the stars. 'Cause you're a sky